Okay guys, here is your next part of this video, the same standard, talking about law of conservation of mass. Here we're going to talk about the compounds and balancing equations, and then do some actual math problems showing how we're conserving our mass, or it's staying the same. So here we go. So law of conservation of mass states that matter can neither be created nor destroyed. It can only be rearranged. So when we have a certain amount of molecules or compounds, we can rearrange them, but we can't create them or destroy them. So mass of reactants is equal to the mass of the products. So we've talked about the reactants and the products. The reactants are on the left-hand side of the equation, and the products are on the right-hand side of the equation. The reactants are what you're mixing together to make your product. So chemical equations must be balanced. Like highlight that, underline it, circle it, do whatever you need to for must be. Write it in big, boldy, shouty caps, whatever. But they have to be balanced, and we're going to work on them. And I'm only going to do one example of showing you a balanced equation here, but we're going to do tons of examples in class. Must be balanced. The number of atoms of the reactants has to be equal to the number of atoms of the products. Alright, so rules for balancing equations. Of course there's rules, it's science. You can never, ever change the chemical symbol or subscripts. So the chemical symbol, remember, is, like for hydrogen would be H, and the subscript would be 2. You can never, ever mess with that part, okay? The only part we can mess with is we can add coefficients to get to the number of atoms we need. And so our coefficients, remember, are the big numbers in front. So if I wanted to add coefficients to this H2 here, I'd have to add a number there. That's the coefficient. That's what we can mess with. We can't ever mess with the element symbol or the subscript. So the coefficient tells you what to multiply every atom by. Alright, so how to balance equations. These are our steps. And then I'll show you an example of a balanced equation. And then in class, we will go over balancing them together. So you're going to count the atoms on both sides of the equation. You're going to add coefficients to get an equal number on both sides if needed. Sometimes you have the reactants numbers, but you don't have the correct numbers for the products, and so you have to add the coefficients there to get them. But sometimes when you add a coefficient there, it changes what you need on the reactant side because of like finding a common factor. So you're going to multiply the coefficient n subscript to find the total number of atoms of each element. And you need to be sure to check that the other elements are balanced afterwards. And so what that means is what I just explained. Once you balance the right-hand side, if you added a coefficient and you multiplied a subscript, you might have changed a factor, and then you might have to go back over to the other side and change the coefficient again to make it balance back out. So here's what it looks like. So you know this equation. 6H2O plus 6 CO2 plus sunlight produces C6H12O6 plus 6O2. And I think probably maybe we didn't make you write the coefficients when we talked about it during photosynthesis. But now is when you're going to learn about those. So this is what's produced. So this side has to be equal to this side. They have to be equal to each other. So you're going to write the So I'm going to write out each of the element symbols or elements here so I can count my atoms and my molecules. So I have hydrogen, and I have 6 hydrogen right here, and I times it by that subscript, and that gave me 12. And then I wrote out oxygen, and I have 6 times. So we have the 6 as the coefficient, and we're timesing it by the subscript 2, and that's giving us 12. Then we have another 6 on the other side with this coefficient, and an oxygen there, so 6 times 1 is 18. Alright, so then we have carbon. So carbon's the same deal. We're taking the 6C right here and timesing it by 1. It gave us 6. So all of that on the left-hand side, all these reactants, have to equal our product. So if we didn't know what our product was, or we didn't know how the balanced part of it, we would have to sort this out and figure it out. So we take our hydrogen and we count those up. And right there, this is a molecule that just has 12 hydrogen. There's no coefficient, so it's just 12 times 1 gives us 12. Then we look at oxygen, and we have oxygen in 2 places. So the first one is 6 times 1 gives us 6. And then in the second one, we have that coefficient times the subscript. So 6 times 2 is 12. Then you have to add those together. 12 plus 6 is 18. So there are 18 oxygen on the right-hand side that were produced. And then we're going to look at the carbons. And again, there's no coefficient there, so it's just 6 times 1 equals 6. So then we're going to compare our right side to our left side and making sure we're balanced. Our reactants were on the left and our products were on the right. Our reactants on the left of hydrogen, 6 times 2 equals 12. And then if you check that on the right hand side, we had 12. That's correct. So then we check the oxygen. We had 18 on the left hand side and we had 18 on the right hand side. They are balanced. And then we had carbon, and we had 6 on the left and 6 on the right. So those were balanced. So that's how you check them to make sure it's balanced. And that's the last step in those, in the how to balance an equation, is be sure to check that the other elements are all balanced afterwards. That's checking it right there. And in class, we're going to do a bunch of examples of actually balancing the equations and figuring out how to do that. Alright, and then we're going to move on to the law of conservation of mass. And this, we're going to go through 2 problems together on here, and then you'll have examples in class as well. So the law of conservation of mass will allow us to determine the amount of a missing reactant or product that was involved in a chemical reaction. So if you were told that 24 grams of magnesium reacted with 16 grams of oxygen and magnesium oxide was formed, how do you figure out how much magnesium oxide was made? Well, we know how much magnesium we had and how much oxygen we had, so we have to have the same amount or an equivalent amount on the other side. So 24 grams of magnesium and 16 grams of oxygen, those are our reactants. Then our magnesium oxide was produced, it was formed, that's our product. So now onto the other side, you're going to write the chemical equation. Magnesium plus oxygen produces magnesium oxide. Now you're going to substitute the mass for each element. Magnesium equals 24 grams, oxygen equals 16 grams, equals magnesium oxide, which is just X. Now you use the mass of the reactants to equal the mass of the products. 24 grams plus 16 grams. You're going to add those together and get 40 grams. So X equals 40 grams. So this one was kind of easy because we knew both of the starting masses, or the masses of the reactants. So then the product had to be 40 grams too. There was no way around it. This next example is a little more difficult. Oh, did you see that? I highlighted that "I'd" to point out, remember I told you that when you make certain bonds, you change the ending there. Always change the ending of the last element to an "I'd." So I was pointing that out to you there. Alright, so here's your second example. If you were told 4 grams of hydrogen reacted with some oxygen to make 36 grams of water, then you could figure out how much oxygen was used. So we've got 4 grams of hydrogen, that's a reactant, and then it was mixed with some amount of oxygen, we don't know how much, so that's like X. And we mixed it with, or made 36 grams of water, so that was our product. So now let's write the chemical equation. Hydrogen plus oxygen equals water. Substitute the masses. Hydrogen, there's 4 grams. Oxygen is X because we don't know. And then H2O equaled 36 grams. Now you're going to use the mass of the reactant. So we have 4 grams plus X equals 36. And we have to solve for that. So I wrote it over here. You know what you do to one side of the equation, you have to do to the other side. So 4 grams minus 4 grams on the left side is minus 4 grams on the right side. That cancels out the 4 grams on the left-hand side and leaves our X alone, which is what we need to do, is get our X alone. And then you have to subtract the 4 from the 32, and that gave us, the 4 from the 36, and that gave us 32. And so our missing value X is 32, so there's 32 grams of oxygen. Alright, so don't stress out. This is a lot of information. We're going to break it down and go over it for the next several weeks. But you need to go back to these videos and look at your fun sheet and take extra notes and see what it's telling you to do at each step and use these as a reference.